right, so today we're going to be looking at slope as a rate of change. Before we get into that, I want to look just a little bit at some more applications of slope. So in the last lesson, you would have looked at the slope formula, so y2 minus y1 over x2 minus x1. You would have also learned that slope relates to the steepness of a line. So I just want to show you a couple more examples that you could be asked in relation to slope. So the first one here says, using slope to plot points. A line goes through the point A, negative 3, 2, so negative 3, 2 would be right here, and it has a slope of negative 3 over 4. And it says to graph the line and give two more points that would occur on that line. And I'm going to show you two ways to go about doing that. One is to just count your slope. So negative 3 over 4 means down 3, right 4. Or it could mean 3 over negative 4, meaning up 3, left 4. And so if we use that as our starting point, we start for our original point and down 3, 1, 2, 1, 2, 3, and then right 4, 1, 2, 3, 4, puts us right here. Down 3, 1, 2, 3, right 4, 1, 2, 3, 4. And we could go the other way, except we don't have enough space on our graph. So those would be some new points. So we would have 1, negative 1, and 5, negative 4. Now, how do we go about doing this mathematically? Well, if I'm going down 3, that means I'm subtracting 3 from the y's. And if I'm going right 4, that means I'm adding 4 to the x's. So 2 minus 3 is negative 1. Negative 1 minus 3 is negative 4. Negative 3 plus 4 is positive 1. And 1 plus 4 is positive 5. Now again, we could have gone in the opposite direction. So I have a negative 3, 2. And if I wanted to do up 3, left 4, then I would have added 3 and subtracted 4. So 2 plus 3 is 5. Negative 3 minus 4 is negative 7. If I wanted to add another 3, 5 plus 3 is 8. And negative 7 minus 4 would be negative 11. So those would be another 2 points on the graph. So this is one type of question you could be asked where you're given a point and then you're asked to find new points. You can do it graphically, but if your numbers are too big to plot on a grid, you could also do it numerically. All right, another type of question that you might get is related to the slope formula, but you know the slope and one of your points is an unknown. So here we have a line that has a slope of 4, so m equals 4, and it goes through a point A, 3, k, so we don't know what k is, it's just like x, and then B is 4, 7, and we're asked what the value of k is. So we're going to be using our slope formula, y2 minus y1 all over x2 minus x1. Always helpful to label your points. And then sub in what you know. We know that the slope is 4. We know that y2 is 7, y1 is k, x2 is 4, and x1 is 3. So simplifying, we have 4 equals 7 minus k, all over 4 minus 3, which is 1. Solving our equation, we multiply both sides by 1, and we're left with 4 equals 7 minus k. So we can subtract 7 from both sides. You could have also added k and subtracted 4. But 4 minus 7 is negative 3 equals negative k. Divide by negative 1, and k equals 3. So you could always sub that back into your equation just to double check that it works. All right, so those are just a couple examples that relate to what we did in the last lesson. We're going to move on and start looking at slope as a rate of change. So this is a sign that you've probably seen before on road signs. You probably know that it has something to do with the steepness of a hill. So the question was, what is the purpose of this sign? Again, I'm sure most of you have seen it before, but you may not know that it's related to grade. So grade and slope are actually the same thing, they're just expressed in different ways. So grade is the slope of a road or a hill or other physical feature. It's generally expressed as a percentage, and the steeper the slope, the higher the percent grade. If you want to find percent grade, it's just slope times 100%, or slope times 100. So rise over run times 100. We're not going to talk about grade really a lot in 10C. If you were taking Math 20-3, we would take this or talk about this in a little bit more depth. But I wanted you to see an example where slope is used in the real world. All right, so we're going to get into rate of change. And the only difference between what we did yesterday with slope and what we do with slope as a rate of change is we include units. So I told you in the last lesson that there are no units when we're talking about slope, and that's true. However, when we're looking at slope as an example of rate of change, we're often looking at line graphs, and we're looking at how one variable is related to the other, and in those cases, we are going to have units. The reason slope units canceled in the last lesson was because our units were equal on the top and the bottom. But when we're looking at rate of change, our units are not the same on the top as they are on the bottom, and so the units won't cancel out. So here's an example. It says Caleb is a student who works part-time at a pizza parlor. He earns $9.50 per hour, and the graph below shows his earnings over time. So if he works 0 hours, he gets $0. When he works 5 hours, he gets $47.50. When he works 30 hours, he gets $285. So the question is, what's the relationship between the rate and the slope? Well, his rate is $9.50 per hour, and it's expressed as a rate because it's dollars per hour. If we were to actually calculate the slope here, so if we took the 30 and the 285, and I don't know, the 10 and the 95, if I use my slope formula, I would have 285 minus 95 all over 30 minus 10. And if I calculated that all out, I'd get 9.5. So $9.50 an hour and 9.5 is my slope. They're the same thing. The only difference between slope and rate of change is typically with slope we don't have units. When we're expressing it as a rate of change, we're going to have dollars per hour or meters per second or whatever our units are for our graph. So we would express this as $9.50 per hour. So slope can be expressed in a lot of different ways. Slope is literally just an example of a rate of change. When we were talking about slope the other day, we were talking about how y changes as a result of x. And this last example we did, we were talking about how money changes as a result of time. So slope just represents rate of change, and it can be written in lots of different ways. The way we did it the other day was rise over run. Okay? It can be expressed as a percent grade, like on the roadsides. And then we can also express it as a rate of change, and that's the one we're going to look at today. In all cases, if we were talking about slope, it's rise over run. If we're looking at rate of change, here our rise units are distance, so distance would be in kilometers. Our run units is time, time would be in hours. So when we divide kilometers over hours, our units become kilometers per hour. So if I want to express slope as a rate of change, again, one way is grade. So 8% slope, 8% slope divided by 100 would be a slope of 0.08. If Connor earns $378 for 28 hours of work, this would be $378 divided by 28 hours would be $13.50 an hour. Now we could also say 28 hours over 378, but then our units would be how many hours per dollar. And that's not realistic when we're talking about an hourly rate of pay. And then the last example here, we have Surrey, BC, grew by 120,000 over a 5-year period, and we're asked what is the population's rate of change. So how did the population change over time? So we're looking at the change in people over the change in time. And so there's 120,000 people over a 5-year period would be 24,000 people per year. So that's PPL for short. All right, so again, looking a little bit more in depth at rate of change. Rate of change is the slope of a line or a line segment that gives our average rate of change. If we were to go further on, if some of you are thinking about heading into calculus, we talk about rate of change a lot in calculus, and we'll talk about average rate of change versus instantaneous, but we're not going there today. All right, so Blair has a part-time job, and he's recorded his hours and pay on 3 different days. And so the question is, what's the slope of the line? Well, we have 0, 0 here. And maybe at 3 here, we've got 3 and 36. And in order to find the slope of the line, I only need 2 points. And so I can use 36 minus 0 all over 3 minus 0. And some of you might say, well, why can't I just go 36 divided by 3? I can, but that's only because it goes through the origin. If this graph went through any other point besides the origin, 36 divided by 3 would give me the wrong answer. So 36 minus 0 is 36, 3 minus 0 is 3, and 36 divided by 3 is 12. But this is rate of change, so we have to consider our units. So meters per, I'm guessing this was supposed to say dollars per hour, not meters. So $12 per hour. Okay. What does the slope represent in the context of this question? Well, slope in this case represents cost per hour or pay per hour. All right. If we want to look at how far Kaylee drove, so we want to figure out the slope of her data. I'm going to choose a point other than 0. So I'm going to choose 2 and 60 and 5 and 150. Again, because these are nice numbers, I could also just draw my triangle and do rise over run that way. So 150 minus 60 all over 5 minus 2 gives me 90 over 3, which is 30, and my units are kilometers per hour. So Kaylee's driving 30 kilometers per hour. What does the slope represent in this case? Well, if I'm driving down the highway at 30 kilometers per hour, that slope is going to represent my speed. So if we're trying to ask ourselves, what does the slope represent? Use your units as the guideline. The rise units over the run units, so kilometers per hour would be speed. Dollars per hour might be pay or cost per hour. And that's the entire lesson. So you have a fairly short assignment to work on just to get some practice with this. Essentially, you're not doing anything different other than adding units. All right, so I'll see you in class tomorrow. If you have any questions, let me know. Have a good night.